Hello everyone, this is Dr. Shaukat Ali from Islamia College, Vaniyambadi, Tamil Nadu, India. The topic for the discussion now is molecular rearrangements. This particular the concept molecular rearrangement is a big chapter. The reason is we have plenty of rearrangements are there, important rearrangements are there. We are not going to discuss all the rearrangements under this module, that is in this particular module. We will discuss only the important rearrangements one by one. And before we enter our discussion into the main topic, molecular rearrangement, it is very essential, it is very important to understand the basic concept behind the molecular rearrangement. To understand this particular concept, let us consider a simple equation in which this particular reactant A is connected with W is converted into AB, in which the B is now connected with your W. Now in this particular reactant, this particular atom A is called as migration origin, because this is the one from where the migration originally starts, and this is the atom called in the name of migration terminus, because this is the one from where the migration is going to terminate, and the W is called as migrating group. The reason is this is the one going to migrate. In this particular example illustrated here, we have only two atoms. This is position number 1 and position number 2. There are only two atoms, atom number 1, atom number 2. From atom number 1, the W is going to migrate, and from that is at atom number 2, it is going to terminate, the reaction going to terminate. Naturally, we get, after the rearrangement is over, after the migration of this migrating group from position 1 to 2 is over, we get naturally a rearranged product, because the rearrangement is taking place here, the migration is taking place here with the help of the migrating group. This is the one going to migrate, this is the one shifts from position number 1 to 2. Naturally, we get a different product. The reason is, in the reactant, A is connected with W, that is the migrating group, whereas in the product, B is connected with the group that was called as migrating group, because here the reaction is over. This is the rearranged product. Therefore, it is very clear that a reaction in which rearranged product, what we get finally as a product, is called molecular rearrangements. Usually in molecular rearrangements, a group that is called a migrating group usually migrates from position number 1 to 2, so called in 1, 2 shift rearrangement reaction. Sometimes the migration may take place far away. It is not essentially to terminate at position number 2. It may end up with 3, 4 or sometimes more than that. And it depends on, that is, when the migrating group moves from position 1 to 2, or in sometimes, that is in some other cases, it may move far away from position number 2. The migrating group may move with its pair of electron, or the migrating group may move without a pair of electron, sometimes with positive charge, or the migrating group may be a proton, or the migrating group may move with a lone pair of electron, that is with the help of a free radical. Depends on the migrating group, whether the migrating group moves without pair of electron, or with a pair of electron, or with the help of proton, or with the help of free radical. We have 4 different types of rearrangement. Say for example, if the migrating group moves from 1 to 2, or from 1 to some other places, that is some other atom far away from position number 2, if the migrating group moves with a pair of electron, usually this particular reaction in which the migrating groups moves with a pair of electron is called nucleophilic rearrangement or anisotropic rearrangement. Nucleophilic or anisotropic rearrangement. So this is very clear that if the migrating groups move with its pair of electron, the reaction will be called as nucleophilic rearrangement or anisotropic rearrangement. On the other hand, if the migrating groups moves without a pair of electron, naturally, if it carries a positive charge, that particular reaction will be called as cationotropic or electrophilic rearrangement. Cationotropic or electrophilic rearrangement. If, for example, if the migrating group is purely hydrogen, then the particular rearrangement will be called as prototropic rearrangement. If the migrating group moves with a free radical, with the help of free radical, if the migrating groups move from one position to another with a free radical, with one electron, the reaction will be called as free radical rearrangement. So it is very clear that we have 4 different types of rearrangement. If the migrating group moves with a lone pair of electron, that will be called as nucleophilic rearrangement or anisotropic rearrangement. On the other hand, if the migrating group carries just positive charge, then the reaction will be called as cationotropic rearrangement or electrophilic rearrangement. If the rearrangement is purely with the help of proton, if the migrating group is purely proton, then that will be called as prototropic rearrangement. Else finally we have a free radical rearrangement if the migrating group moves with one, that is with just one electron, if moves from one position to another. So I repeat again, molecular rearrangement, the concept is very simple. If the rearrangement, in the case of molecular rearrangement, a group called migrating group moves from position 1 to 2 inside within the molecule, so that finally we get a rearranged product, because the rearrangement is taking place by moving the W, that is so called the migrating group, from position 1 to 2. In this particular example given here, we get a rearranged product. Therefore this concept in which the rearranged product is formed simply by migration of this, with the help of, after the migration of this W from position 1 to 2, we get a rearranged product. Therefore this is called molecular, this particular reaction in which what we get, the rearranged product, finally is called molecular rearrangement. Depends on the migrating group moves from a pair of electron or without pair of electron, or with the help of proton if the migration is with the help of proton, and if the migration is because of free radical, we get different names. Nucleophilic if the migrating group carries a pair of electron, electrophilic if the migrating group carries positive charge, prototropic if the migrating group is proton, free radical rearrangement if the migrating group carries just one electron. With this, I am concluding an introduction of molecular rearrangement. In the next module, we will see the specific example. Thank you.